Welcome. My name is Sophie.
And my name is Aria.
And today we will tell you something about the work that we did on an adaptive computational model applied to Genito-Pelvic pain penetration disorder. And this is work that we did together with Jan Treur and Paul Ensling. 1 out of 5 women experience vaginal pain during coitus, and there are many different terminologies. But genito-pelvic pain penetration disorder, or GPPPD, is the most recent in the DSM-5, and mechanisms underlying this are still poorly understood. Sexual pain disorders have a comorbidity with other disorders and diseases, both physical and mental, and in addition, repeated pain during coitus has a substantial negative impact on the quality of life and has an altered sexual functioning. The etiology of GPPPD is multifactorial and complex, and this means that biological, psychological, and relational factors interact to perpetuate and maintain a woman's pain response. GPPD should thus never be viewed as purely medical or a psychogenic problem, but always evaluated and treated from a biopsychosocial perspective. There are different therapies, but there's currently not one therapy that's effective for all individuals. People with sexual pain disorders generally try many different treatment modalities, often over the course of many years, before experiencing any significant relief. Multidisciplinary treatment in chronic pain has held strong support, but it's relatively new for sexual pain specifically. And in order to create multidisciplinary treatment programs that fit for individual cases, the underlying mechanisms of vaginal pain should be better understood. And there's still a lack of theoretical models right now that describe the psychosocial mechanisms involved in the development of GPPPD.
We adapted this model from a well-established fear-avoidance model. As you can see, the injury, which can be either physical or mental, triggers a pain response. Pain evolves into catastrophization, which then in turn leads to fear. Fear, again, leads to both vigilance and avoidance. Vigilance can lead to a lack of arousal, which feeds back into more pain. Simultaneously, avoidance leads to dysfunctions and feeling of distress, which also adds to the pain response. This leads into a spiral of pain. For our computational model, we extended the fear-avoidance model by adding 2 control states and a reification level, which you can see in the blue plane. The circular part is the same as in the previous slide. But let us take distress as an example of our elaboration. Distress causes the patient to become aware of the distress. This awareness can be interpreted as a control state, where awareness of the distress lowers the emotional state to some degree. On top of this, the control state and the distress state feed into the first reification level, which in turn affects the control state. This process we call Hebbian learning. You could choose to add control states for all emotional nodes in the model. We started off with these for 2 reasons, the first being computational, and the second one is that based on literature, the most common therapy for GPPD targets catastrophization and distress. The idea is that therapies will target this control state instead of the emotional state directly in a more natural way than if we were to model the feelings of catastrophization and distress directly. As you can see, we modeled all the states. The adaptive model shows a peak in experienced pain after an injury. Let us highlight on a couple of these states. Here we have the same figure, but we left out some of the other nodes. As you can see, there's an injury which starts at 1 and causes a peak in the pain. Although the pain does go down eventually, it activates the fear avoidance cycle. We see that fear in green goes up, which results in elevated levels of distress and lack of arousal levels, which are yellow and red. This in turn increases the pain again. Now we further elaborated on the model by adding a therapy node to the adaptive model. We can see that in the left of the pink plane. Therapy gets activated by the pain experience, and it targets either or both of the control states in our model. So how well does this work for our GPPPD woman when targeting the catastrophization control state? Again, we have the initialization of the fear-avoidance cycle after the pain response, but now we see that the pain gets out of hand. The therapy kicks in and successfully targets the control state. The psychoactivity seems to be broken. However, when you look at a larger time scale, the therapy is not strong enough to successfully suppress catastrophization state. And we are caught in this loop where therapy goes down because the pain goes down, but then the pain goes up again because it's not down, it's not low enough yet. This leads to this cycle where you don't get out of. So what if we target both control states? Indeed, we see a therapy that targets two parts in the system is stronger than a therapy targeting only one. Let us look at a couple of these states. Here again, we simplified the graph. And when the pain becomes high enough for the woman to decide to go to therapy, it successfully breaks the fear avoidance cycle on a more sustainable term. Now, this patient is fictional, but in our paper, we've also validated the model with data from real-life patients.
So what can we conclude? We present that targeting multiple states is more likely to break the cycle. And this supports the notion that multidisciplinary approach is effective in getting out of that fear avoidance spiral. For future research, could collect more empirical data of different states before and after therapy. And adding more control states to the model would also create a more elaborate model that will be able to characterize more kinds of therapies. And this would thus be effective of therapies specialized for different kinds of individuals. Another future extension of the model may be to incorporate metaplasticity by making the learning speeds and the persistence factors adaptive. A second-order adaptive network is obtained, taking into account the effect that circumstances may have on a person's learning capabilities, and that even may block learning. This work that we did here is a great starting point for multidisciplinary treatment plans for women suffering from GPPD, so that in the end we can create different kinds of therapies for different kinds of women. These are our references, and thank you for listening. And if you have any questions, please let us know.